This is Twitter Think, and in this video we are talking about the range and domain of a function. Perhaps we may have come across the topic before and now would want to understand one or two things. So let's watch this video and go through the following explanations I'll give to be able to tackle one or two questions. And I'd advise you do not forward this video. It's very important that we talk about the basic things we need to understand. So we have here function, domain, and then the range. What do we mean by functions? When we read books, we are told that the function is a relationship between two quantities called the input and the output. And we are told that for each input, there is exactly one output. So I have here a given function f, the set of x values, also known as the input, is equal to the domain, and the set of y values, also known as the output, equals to the range. So when we have a function f of x, for instance, I have here f of x is equal to, say, 1 out of x. We say that the function f of x is undefined when x equal to 0. What do we mean by that? When we substitute the denominator x equal to 0, the function cannot be solved. Again, when we consider the function f of x equals to square root of x, we say that square root of x, or x, is not defined when x is negative. If s is negative, we will get a negative square root. We are not interested in complex numbers, and so we cannot use this for functions. So we are saying that the rule number one is that the function f of x must not be divided by 0 like how we have here, and also we must not get a negative square root. Then how then can we find the domain of the function? So to be able to find the domain of the function, we must first find the values for which f is not defined, like I explained earlier. Once we are able to get the value for which x, or the function f of x, or whatever function given to us, is not defined, we will be able to find the values that make the equation defined. For instance, we can put 1 here and this equation will be defined. That means f of x will be equal to 1. When we substitute 2, f of x will be equal to 0.5. When we substitute 3, f of x will be equal to 1 over 3. Here too, when we substitute 0, f of x will be equal to 0. When we substitute 1, f of x will be equal to 1. When we substitute 2, f of x will be equal to, I think, 1.4. Yes, the root of 2, 1.4. So we are interested in positive values here, not negative values. And we are interested in values, any other value apart from what? 0. So for this equation, we can say that x is greater or equal to 0, such that all the values here, it's 0, 1, 2, up to infinity. So we can put these values into the equation and make it define. And this is the domain of f of x. This is the domain, positive values. So if we consider the function q, r, s, t, u, 1, 2, 3, 4, we know that q is mapped to 1, r is mapped to 2, s is mapped to 2, t has nothing, and u is mapped to what? 4. So the domain is the set q, r, s, u. Q, r, s, and u are the domain. T here is not a domain because a function here, these values, none of it has been defined for t. So t here is not what? It's not a domain. So t is not a domain since a function is not defined for t. Again, the range is the set 1, 2, and 4. So when we come here, the range is the set 1, 2, and 4. And 3 here is not a range because it has not been mapped to any of the what? Of the domain. Do we understand? So since there is no letter in the domain that is mapped to 3, 3 is said not to be what? A range. So this is the basic concept of range and what? And domain. I hope we got the concept through whatever we have here. So we would take an example and see how we go about it. For instance, if we have a function like f of x equals 1 out of x minus 3, how do we find? We will be asked to find the range and the domain of the function. So first we find the domain. To be able to find the domain, we learned that the domain are possible values that will make the equation what? Defined. And these values that will make the equation defined, or these values that will help us to be able to solve this function, are plenty. They are not, it's not a one value. So to be able to find those values, we need to find a particular value that when we fix into this equation, it will be undefined. We can't solve it. And then we will use it to find the values that are what? Will help the equation to be what? Defined. So that is how we go about it. So to be able to do that, all we need to do is to equate the denominator to what? To 0. And to do that, we write a statement and we say that for f of x, the function given to us, this is the solution to be defined, because we are interested in getting the values that will make the equation defined. To be defined, x, the denominator x minus 3 must not be equal to 0. That is, x must not be equal to 3. So we can say that therefore we are done. That is it. I put 3 into the function x. It will give me something like 1 out of x minus 3. And x here is 3. I'm citing an example. The denominator here becomes 0. And 1 over 0 will be undefined. So that means 3 is the value that will make the equation undefined. The remaining values up to infinity will make the equation what? Defined. And so once we are able to get that value that will make the equation undefined, then we can write a statement by saying that the domain of the function given to us, f equals, bring curly bracket like this, x is such that x is a member of all imaginary real numbers. X must not be equal to 3. And we close it. And this is our answer for the domain. So any other value substituted into the equation f of x will make the equation defined, but 3 will make the equation undefined. And so we are done with the domain. What about the range? How do we find the range for the question? The range are the output values. These are the y values. And so to be able to solve, we need to equate the function f of x to y. Once we are able to equate the function f of x to y, the next thing to do is to find the inverse of the function f of x. And once we are able to find the inverse of the function f of x, we look at the denominator and we repeat the same steps we have here. And we will be able to find the range of the equation. So to do that, we say that let y be equal to f of x. So now the f of x equation given to us is 1 out of x minus 3. So you say y equals 1 over x minus 3. The next step, to be able to find the inverse of the equation, we need to cross multiply. I said that the basic step is that to find the range, you equate the function given to you to y. After doing that, you find the inverse of y, or of the equation, the inverse of f of x, with the help of the new equation we have formed. Now the third step is to equate the denominator to 0 to find out the value that will make the equation what? Undefined. And that is what will give us the values of the what? The range. So now we do cross multiply here, and we have something like y into bracket x minus 3 equals to 1. So we can multiply through and get xy minus 3y equal to 1. So I want to make x the subject. To be able to find the inverse of the equation, we make x the subject. I repeat, make x the subject. So to make x the subject, I carry this one to the right side. Those of us that know, you can do it. Those of us that do not understand or need the basic step, I'm doing it for your sake. So we have x, y, I'll maintain it because I want to avoid negatives, equals to 1 plus 3y. y. Now I want to make x the subject. I divide through by y. Here over y, here over y. I can cancel y out. So now my x will be equal to 1 plus 3y out of what? Y. And this x here equaling to 1 plus 3y over y is the inverse of the equation f of x. Once you are done and you get here, you are able to make x the subject. You write what we call a statement by saying the function given to you is f of x. So you write f inverse of y equals 1 plus 3y out of what? Y. So now we will look at the denominator. Once we look at the denominator, what is it that when we do here, when we equate this denominator to 0, the equation will be undefined. So when we equate this to 0, if y equal to 0, and we always consider the denominator, and we cannot find the range. So we do not want this one to be equal to what? 0. So we say f inverse of y is defined if y is not equal to what? 0. So y must not be equal to 0. All other values apart from 0 will make this equation what? Defined. So now we write a statement for the range as our final answer by saying range of f, the range of the function f equals f of x. We are interested in the function f of x, not the value x like in the domain. This time you don't say x, you say f of x is such that f of x is a member of all imaginary real numbers. The values are a member of all imaginary real numbers. F of x must not be equal to 0. This means that if it must not be equal to 0, then it must be equal to 1, it must be equal to 2, it must be equal to 3, it must be equal to 4, and any other imaginary real values will make the equation what? Define. So the most important thing for us to do is when you get here, all you need to do is equate this to what? 0. If it were to be something like 1 plus 3y out of 2y plus 2, then all I need to do is that 2y plus 2 equal to 0, 2y equal to minus 2, y equal to minus 2 over 2. So y equal to what? 1, minus 1. Now if y equals to minus 1, once I substitute minus 1 here, the equation will be undefined. So in your answer for the range statement, you say range of f is such that f of x is a member of all real numbers. F of x must not be equal to what? Minus 1. Because when I put minus 1 here, I make the equation what? Undefined. But we need values that will make the equation defined. So f of x, the range y, the value here must not be equal to what? Minus 1. I hope this video was helpful. In our next video, we will talk about other 1 or 2 questions there for us to really get the concept of what we are doing. So this is range of a function part 1. Subscribe to this channel if this was very helpful to you.